Question 13. What is the difference between FDD and TDD? Answer. FDD equals frequency division duplexing. Transmitter and receiver operates on different frequencies. TDD equals time division duplexing. Transmitter and receiver operates on same frequency. Question 14. What is an extended cell? How does it impact the system, channels and TDMA structure? Answer. The current limitation on the range of a GSM cell site to 35 km is mandated by the duration of the standard time slots defined in the GSM specification. The maximum distance is given by the maximum time that the signal from the mobile BTS needs to reach the receiver of the mobile BTS on time to be successfully heard. At the air interface, the delay between the transmission of the downlink BTS and the uplink mobile has an offset of 3 time slots. Until now, the mobile station has used timing advance to compensate for the propagation delay as the distance to the BTS changes. This timing advance is defined in the GSM specification as 64 bits, which gives the theoretical maximum BTS/mobile separation as 35 km. With extended range cell feature, the BTS is able to receive the uplink signal in 2 adjacent time slots instead of 1. When the mobile station reaches its maximum timing advance, i.e. maximum range, the BTS expands its hearing window with an internal timing advance that gives the necessary time for the mobile to be heard by the BTS even from the extended distance. This extra advance is the duration of a single time slot, a 156-bit period. Question 15. Why do we use multiple access schemes? What is the difference between FDMA, TDMA and CDMA? Answer. Multiple access schemes allow for many users to access the network. FDMA equals users access the network through frequency division. Separation between users is made through frequency. 1G cellular systems. TDMA equals users access the network through time division. Separation between users is made through time. 2G cellular systems. CDMA equals users access the network through code division. Separation between users is made through code. 3G cellular systems. Question 16. What is a physical channel? How do we differentiate between physical and logical channels? Answer. Each time slot on a TDMA frame is called a physical channel. Therefore, there are 8 physical channels per carrier frequency in GSM. Physical channels can be used to transmit speech, data or signaling information. A physical channel may carry different messages depending on the information which is to be sent. These messages are called logical channels. For example, on one of the physical channels used for traffic, the traffic itself is transmitted using a traffic channel (FCCH) message, while a handover instruction is transmitted using a fast associated control channel (SCH) message. Question 17. Why do we need FCCH, SCH, and BCCH? Answer. FCCH identifies BCCH carrier by the carrier frequency and synchronizes with the frequency. Synchronization channel SCH transmits information about the TDMA frame structure in a cell, for example frame number, and the BTS identity, base station identity code BSIC. BCCH broadcasts some general cell information such as location, area identity, LAI, maximum output power allowed in the cell, and the identity of BCCH carriers for neighboring cells. Question 18. What is the purpose of PCH and CBCH? Answer. Paging channel PCH transmits a paging message to indicate an incoming call or short message. The paging message contains the identity number of the mobile subscriber that the network wishes to contact. Cell broadcast channel CBCH BS uses this logical channel to transmit short message service cell broadcast. Question 19. Explain the structure of a traffic multiframe. Why do we need switch and idle bursts in a traffic multiframe? Answer. Traffic multiframe structures. The 26 traffic multiframe structure is used to send information on the traffic channel. The 26 traffic multiframe structure is used to combine user data, traffic, slow control signaling, switch and idle time period. The 12th frame, number 13, in the 26 frame traffic channel multiframe is used by the slow associated control channel switch, which carries link control information to and from the MSBTS. Each time slot in a cell allocated to traffic channel usage will follow this format, that is 12 bursts of traffic, 1 burst of switch, 12 bursts of traffic and 1 idle bursts. The idle time period allows a mobile device to perform other necessary operations such as monitoring the radio signal strength level of a beacon channel from other cells. Time interval of a 26 frame traffic multiframe is 6 blocks of speech coder data, 120 ms. Question 20. What do you mean by YAP? Answer. Effective isotropic radiated power (EIRP) is the amount of power that a theoretical isotropic antenna that evenly distributes power in all directions would emit to produce the peak power density observed in the direction of maximum antenna gain. YAP can take into account the losses in transmission line and connectors and includes the gain of the antenna. A YAP is often stated in terms of decibels over a reference power emitted by an isotropic radiator with equivalent signal strength. The YAP allows comparisons between different emitters regardless of type, size or form. Question 21. What is polarization? What are the types of polarization? Answer. The polarization indicates the plane in which the wave is vibrating. The polarization plane is taken to be that of the electric component. Vertical and horizontal are the simplest forms of polarization, and they both fall into a category known as linear polarization. However, it is also possible to use circular polarization. This has a number of benefits in areas such as satellite applications, where it helps to overcome the effects of propagation anomalies, ground reflections and the spin that occur on many satellites. Circular polarization is a little more difficult to visualize than linear polarization. However, it can be imagined by visualizing a signal propagation from an antenna that is rotating. Question 22. What is Rayleigh fading? Answer. Rayleigh fading is a reasonable model when there are many objects in the environment that scatter the radio signal before it arrives at the receiver. Rayleigh fading models assume that the magnitude of a signal that has passed through such a communications channel will vary randomly or fade according to a Rayleigh distribution, the radial component of the sum of two uncorrelated Gaussian random variables. Rayleigh fading is most applicable when there is no dominant propagation along a line of sight between the transmitter and receiver. If there is a dominant line of sight, Rayleigh fading may be more applicable. Question 23. What is multipath fading? Answer. Multipath fading is receiving multiple copies of the signal at receiver due to reflections. The copies reach the receiver with different phases, so summation either constructive or destructive. This affects the quality of received signal in terms of B. Question 24. What is fading? Answer. Fading is the variation of the received signal with time. It occurs due to propagation distance. Short-term, fast fading caused by multipath propagation. Long-term, slow fading caused by shadowing.